Hello everyone, welcome back. My name is Marcos and today we're going to talk about long overdue subject, which is structs, methods, and interfaces. Let's go. Let's go everyone. So just before we start, just a quick reminder that the content that we have been using here is from a website called gobyexamples.com. The link will be on the description below. It's an amazing website. Please take a look. There is also a GitHub repository, which we have been using to show the examples. It's a great way to learn Go, learn by examples. And with that said, let's go. So today we have structs. So as usual, I'm just gonna take on my terminal here on the right side. I'm gonna take a look and see if I have any further changes, which I do not. Clear the console, and let's take a look here on the example. Let's execute it. So go run dot. Actually, my mistake. We need to be on the examples. Open the structs. Here we go. And then I'm gonna run it. So what is structs? Structs is by Go definition, is a typed collection of fields. They are useful for grouping data together to form records. If you do come from another language background that is mainly use classes as an example, like C# or Java, just think it as a lightweight version of class, which by the way, those languages also have structs. It just, I perceived not to be as much used as classes, but in Go, we just have structs. The idea is, let's just take a look here on the syntax wise. The example that provided to us is there is a struct called person. This person struct has two fields, which is a name and an age. It is a string and integer. Please take a look here on the actual syntax itself. It's very simple. You start with the type, you specify the type name, and you say it is a struct, and then open curly brackets and there specify the fields. And you go below here on the code on the line 16, you see there is a function called new person, and this new person accepts a name, and it returns a pointer to a person struct. Right, so right here inside, we pre-assign whatever is being passed on the parameter here as name, we assign to a new variable person. You see the syntax on how to initialize a new struct. You just say the type, and then you open curly brackets so you can specify the properties right away. In this case, for this particular example, it was chosen to just pre-specify the actual name, and then afterwards you can see that you can access the struct properties or fields just by typing dot, so like p dot age, and you can specify the variable, and you can assign a variable, in this case 42. So everybody that every time you're gonna call this function, the person's age will be predefined as a 42 years old. And also because you're returning a pointer, you just put it end sign here. So we saw that the results here on the right side. Let's just understand one by one and walk through it, right? So this syntax creates a new struct, right? And actually, let me put it here a little bit up. So we are printing a new person, a struct person, but look at this. We specify the values right away. So this person is called Bob and is 20 years old. We're not calling the function new person here yet. We're just specifying right away. So pay attention that the order of the fields matter. So because you specified Bob here is because the name is the first field of that particular struct. So that's why it works. So you print this, and on the FMT package, the way it shows the structs is just like, open the curly brackets and go field by field, just the actual values. You don't see the actual property name in here, for example, name and age. Just moving on, another way that you can initialize a struct, you specify the actual property names and then you assign a value. So for example, in this case, you say, hey, it's a person, and then the first property you assign. Now the order doesn't matter because you're specifying the actual property names, the field names. In this case, the name is Alice and the age is 30 years old. And then we have here Alice, 30 years old. Just a quick tip here. I've touched it a couple times on my videos. Readability is important. In this particular case, we're just seeing an example of a struct with 2 fields, but I would highly recommend avoiding, specifying struct like this way, unless it is a small, struct. But for readability purposes, it looks better for the reader, for the maintainer of that code to actually see the properties like, the example number 2. Another thing here, omitted fields will be 0 valued on the third example. So for example, we specify person and say just Fred. This will work because you specify the actual name. As a funny thing is, if for example this, once again trying to convince you to use the always being explicit about the property names, if you do this, it will complain. It will not allow you to do that, because you're not specifying, like, Go does not know how to initialize that struct because it does not know what this property is. You need to specify all properties. So that's kind of one of the downside there. But in any case, when you're specifying, being explicitly about the property names, you can just see it like that, and you don't need to specify the age. In this case, Fred is 0 years old. Let's continue here. So you can add the end prefix that yields a pointer to the struct. So that's kind of a simple, every type in Go allows you to be either a value or a pointer. So this is no surprise that you can add a end here, and actually, it becomes a pointer. So when you print it, it just adds that value here at the beginning. Just moving on. And now look at this. It's idiomatic to encapsulate the new structure creation in a constructor functions. So what it's saying is, most of the time you're going to have these, constructors, and because this is a struct, not a traditional class on some other, languages, we don't have a ability to specify methods or constructors inside of the struct. So you need to specify to create a constructor outside. So yeah, it just says function that returns a person. But you're going to see that a lot. That's the point here. I think that's what they're trying to say on this comment. It's standard to always have a function to pre-initialize a particular struct. And this is my favorite way to initialize, which is similar here, just because in this case we are assigning the actual. Oh, I clicked it by mistake. Coming back. It just will assign this into a variable. So what you do is just specify the person the same way that we are doing here with Alice. In this case, it's Sean, and Sean is 50 years old. But in this particular example, it's just trying to say once again that you can use a property name just by accessing with the dot. So you just say, in this case, it's just printing the Sean's name, not the age, his age. So Sean just says a name right here. Just moving on, so you can also use dots with struct pointers. The pointers are automatically dereferenced. So this is a nice thing is, you see here, it's just taking a Sean as a struct on the variable s, and now sp, which is also a struct, but this case is a pointer. You don't need to change the structure, the syntax wise to access that. You just right away sp.age and then go dereference that behind the scenes and make it easier for usage. I think that's awesome. And this is kind of obvious, but it's good to be explicit. Structs are immutable. So you can change, meaning you can change the value of its fields essentially. So in this case here, sp, it's changing to 51. So we printed here before 50, now it's 51. Because by the way, because it's a pointer, we are changing Sean's age right now to 51. That's pretty much it for struct. Just one more thing, and I think it was not very explicit here. So, I mean, it's kind of obvious, but I just want to make sure that we understand this. A struct is a group of fields, meaning it can also have other struct. Right, so let's just create a quick here, like for example, this is a person, right? So let's just say occupation, for example. So we're gonna create one occupation, which is a struct, and then occupation we can have the the job title. Let's just say like name, like the job name or occupation name, and then let's just say salary as a float. 32. So in this case we have a struct. So in order to use this struct, we can have another property here. Let's just say occupation lowercase, and then the type of occupation. Now a person has an occupation property, which is another struct. Obviously, some things here were broken. Oh, once again, this syntax broke one more time. Oh my god, don't use this syntax. I mean, unless you have a reason, obviously, etc. But because actually it's a good thing. Maybe, you know, you just added on your code this new property and you want to make sure that this property is initialized everywhere that is being used, and you want those errors, right? Like those compilation errors. Maybe that's the case. I don't know. But in this case here, because you're specifying the values, you need to specify occupation as well. Visual Code, you do a control tab, it auto-populates that for you as an occupation, and open curly brackets there. It's nice thing about my theme, each time you have a curly bracket, it changes the color, so it's meaningful that you know, like in this case, yellow is for the occupation here. Continue to do a control tab. We can specify the name of the occupation. Let's just say that the name of this occupation is, I don't know, developer. And then the salary, I was just gonna say like randomly just 1,000 here, not to say anything. So let's just run it one more time to see if it works, and hopefully it does. Here we go. So you just say, hey, Bobby is 20 years old, and there is another struct. It doesn't specify here on the FMT, the print line, but it just, you know, developer, which is the occupation name, and 1,000, which is the salary. All the other syntax did not break, but, you know, I just wanted to be explicit that you can also have other structs. There is another subject called struct embedding, but that will come from to another video. And with that said, that's everything for structs. Let's go for methods. So methods, let's just close here, struct, and then we go here for methods, and then I go one folder up, and then go inside methods. Here we go, clean this, and as usual, let's run, and then we have the results right away for a reference, and let's just take a look, right? So methods. So I want to do a quick correction, not a correction, but it's more like being a little bit more precise. So one of my earlier videos, I said that functions and methods are pretty much interchangeable, you know, terminologies to some extent, and maybe some languages they are. But if you want to be very like strict about the terminology wise, the answer is actually no. Functions and methods as a word in programming does have a difference in depending on the language. So let's just clarify it here right away. So function, the idea of a function is just it's not, you know, related to an object per se, like a struct or a class or anything like that. You can just call by its name, and it may or may not have parameters, and may or may not return something. So it's like very standalone, and like it doesn't need to be attached to anything. As opposite, a method is attached to an object. So like you are executing an action on the top of an object, and therefore you, in theory, can access the properties of that object inside of a method. So that's a slightly difference in terminology. The reason why I was biased on this terminology is because I came from a C# background mainly, and Java, and there is no functions there. Turns out that, like, you know, everything is just methods, because even if you created like a main program on those languages, you need to specify at least one class, which is usually like, you know, the starter class. They call it like program or something. But here in Go, we don't have that concept, right? Like you can just have a function main on a given file and execute it, and you're good to go. You don't have like a class or struct to execute it. So like, yeah, so those languages always just have methods, and by we I mean C# developers, they have a tendency to just call it functions time to time. But guys, if you are a C# or Java developer, use the proper name. All right, let's continue. So the idea of a method, as I said, it is attached to a subject, and that's what we're going to show it here. So we just saw what is a struct is. So like they're already taking that into usage. Well, that's obligated to the subject anyway. So we have a rectangle struct, shorter for rect. And there's a width and a height, both an integer. And then there is a function here. Look at the syntax. That's very important, right? So this function is called area, returns an integer, right? And this is the code of the function itself. The area for a rectangle is just multiply by each side. But the more important thing about the syntax here is this portion right here, which is this function is applied to an object called, of type rectangle. And because we can access its properties, it must be assigned to a variable, and the variable is r. So you start with this function, it will apply to r as a variable, and then the type is rectangle. So in other words, every time you have a struct rectangle, you can just call this by dot. And we're going to see that in a second. You can just call it. Let's continue here reading the code before we see like the usage a little bit further. So methods can be defined for either a pointer value or receiver type. This is an example of a value receiver. So yeah, this is an important distinction here. So this function is applying, this method is applied to rectangle, but it is a pointer for a rectangle. And what they want to say here is like, it doesn't matter. It can also be just rectangle. It doesn't matter in terms of syntax wise, but there is a difference, right? Like it's kind of an obvious difference. The difference is this function right here. If you change the value of the rectangle, you're going to change to the object itself, to the memory of that object. And this one, it will not. It will create a copy of it. That's that's a standard pointer thing. But yeah, so like an advice tip for engineers there: if you do use it a pointer, mean it, right? Don't like randomly always just use pointer. If you want to use a pointer, like make it meaningful in such a way that you are modifying the struct values inside of that method. And same thing, if you do not use it a pointer, is the same as you saying to the consumer of your methods, like, okay, I'm not going to change the property names of this, in this case, the structure. So you don't need to, take that in consideration of your upstreams logic, pretty much. Anyway, let's continue. Right, so function main here. So we're defining on the line 23 a struct called rectangle, and the variable is going to be r. And as we know, like the syntax, we can specify the properties right away. This case is using named properties, love that. So 10 and 5. And then what we do here, we do two prints right away. So we printed area, so we call r.area. Look at this. So now the struct has a method, right? So you can right click and you can go to definition and you jump into the line 12 here. It almost feels like you are doing, it's a class, right? For those that comes from those backgrounds. But the syntax wise is slightly different. And there is a lot of advantages here. So one example is the structure itself, the file, or like even just the structure is very lightweight. And you can specify the methods in like somewhere else, even some other file if you want. Same package, but some other file. Just pretty much, it gives you some flexibility, and that's awesome. So yeah, so it prints first the rectangle area, so that's what we see here. So area colon and the area, so the area for the rectangle is 50. So 10 times 5 is 50. Here we go. And then the perimeter here, which is 30, is the sum of all the areas of that particular rectangle. And then now it shows another nice detail here. So Go automatically handles conversion between values and pointers for method calls. You may want to use a pointer receiver to type to avoid copying on the method calls, or allow your method to mutate the receiver struct. This is exactly what I said earlier. If you're doing this, mean it, like you're actually changing the values there. Another thing about Go here, like you can just, we're creating a variable RP that is essentially pointing to the same variable r, and now RP is a pointer of rectangle. But look at this, area accepts a pointer, that's fine. The perimeter does not, but it works, right? Like a perimeter right here on line 18 is not taking a pointer, but it accepts anyway, and that's awesome. It creates some flexibility on Go. That means that if I, in the same way, if I remove this pointer right here, the code, theoretically speaking, should just work. In this particular case, it should work just fine because we are not, modifying the value inside. And yeah, that's everything for methods. And let's go next for interfaces. So interface is another fun subject. So let's go close methods here. And then we go one folder up, and then interfaces, and then clean. Here we go. So interfaces. So let's see the definition here first. Interfaces are named collections of a method, right? And method signatures, to be more precise. So it's another type. Let's just take a look here on the line 12. Actually, let me run it first, right? Go run dot. Let's see the values, whatever that is. We're gonna read the code in a second and understand this output. So the type geometry is an interface. And the interface, look at the syntax, right? And by the way, if you don't know what an interface is, the idea is a contract. It's like, okay, this object represents a contract. So whoever calls it, I ensure that those contracts can be met, and you're gonna have those parameters and returns as specified on the contract. So in this particular case, the interface geometry has whoever is implementing this, partially anyway, we're going to see that in a second, there is a method called area, and the area does not accept any parameter, but it returns a float of 64 and a perimeter that does not accept any parameter, but it returns a float of 64 as well. And what we are doing here is next we have some two structs being created. We have rectangle and circle. The rectangle has width and height, and the circle just radius. And look at this. Now that we learn struct and method, we are finally able to see this here. Look, we understand the syntax because it's a method that is applied on a rectangle. The method name is area with no parameter. And then the return is a float 64. You don't need parameters because you have you can access the property fields, the fields values just by our dot, which is the variable here, right? But look at this, it doesn't say that it's geometry, right? Like if you search, this method that is applied to rectangle so far has no connection with geometry so far at this point, right? But it does implement it. We can actually, you know, like for example, search this here and you see that it's exactly same syntax, just to make sure that, you know, we are having the same syntax. And yeah, so the rectangle is also implementing the second, in this case, a method for the rectangle object, which is just perimeter, also returns a float parameters, and the implementation differs slightly, and that's pretty much it for the rectangle. We do the same thing for the circle. So circle here is looking the same, but instead it's applying to rectangle, is applying to a circle, and the variable that is accepting that is C. Just one quick neat thing here that was not mentioned. We are using, this example is using a package called math. This is a default golang package, and there is a constant of pi that just returns the pi value. So right here, and then you can do the area and the perimeter for the circle. So that's good. Now let's actually, yeah. So let's take a look here. Yeah, let's read this first. So if a variable has an interface type, when we can call methods that are named in interface. Here's a generic measure function taking advantage of this to work with any geometry. So look at this. This function, it is accepting a variable g of type geometry. So it doesn't know what property, it doesn't know if it is a rectangle or a circle or whatever that is. All it knows is, okay, I have the ability to maybe you know, access myself. In this case, just print it itself, but it cannot access any properties per se, or just the methods, right? And another thing is, I know that the interface has two functions, or in this case it's methods, but anyway, so is a dot area and a dot parameter. So you're just doing that right there, right? So like if you go to the definition here, you know, obviously you go to the actual interface. It doesn't know which implementation it is. Now let's take a look here on the neat thing, right? Like remember, a rectangle or circle has not explicitly said, hey, I implement geometry. The way it works in Go is slightly different. Let's take a look. So line 55, we're creating a rectangle and we're specifying the field values right away, 3 and 4, and the circle is 5. So it says here, the circle and rectangular structure types both implement geometry interface. Yes, they implemented that because we saw the code, but so far we have not seen that, you know, in action. And then so we can use the instances of the structs as arguments to measure. And it's like of a casting. Look at this. The measure function is accepting geometry, right? And then on Go, you specify, hey, I'm passing R. But Go is like, okay, during the compilation time, it doesn't match. Okay, so like, does the rectangle truly is implementing everything that it says, right? So if in a rectangle here, I put like another name like area B, for example, it no longer implements that interface. When I mouse over it, it was like, hey, I cannot use R, which is the type of rectangle, as a geometry value, because it does not implement geometry. It's missing method area. It actually says the name. So that's awesome. So yeah, so it's pretty much like, you know, compilation time, and on your IDE as well, you will recognize if it is implemented or not. You're not doing that explicitly as opposed to some other languages. And yeah, and the same thing with letter C, which is a circle, and just call it a measure right there. So let's take a look here. So the function geometry for rectangle will be the top 3 values. So first you print itself. We know that when you print a structure, you do not specify the names, just the values. So it's 3 and 4 by the order of the rectangle here. That will be the width and height. So that's it. And then you do the area. So the area of that rectangle is 12, and then the perimeter, which is 14. Next, you call measure function once again, but this time with a circle. And then within the geometry interface, the circle only has one value, which is, you know, 5. In this case, 5 is the radius. And then we continue here doing the area, which is the area of this is, you know, 78.53 and all those numbers, which is a float. And last but not least, you do a perimeter of that circle, and it's 31. So just before we close here, this adds a lot of flexibility to Go. Like, you don't need to specify the interfaces. So whenever you specify a struct, you don't need to be like, hey, this is geometry, or like, you know, some similar syntax. So it becomes more lightweight, and the struct itself, it doesn't matter. It does not know what it implements. The implementation goes somewhere else, and, you know, Go understands that, like, you know, into the compilation time, and your IDE will save that right away. So it's a lot of very much flexible, and I love that about Go. And just one last thing before we close this video today. Go, this is more like a, you know, a recommendation on Go. Typically in Go, you'll find that interfaces are usually like 1 or 2 methods long. As opposed to some other languages, you may have, like, you know, a heavy load of different functions. It's just the way that the Go language is structured. Just Go is the structure. It becomes a little bit more readable and maintainable in that sense. We're gonna go a little bit more details, but that's pretty much it. For interfaces, very, very flexible and lightweight. And yeah, that's pretty much it for every day. Thanks very much. If you like the content, please give it a like and subscribe to the channel. And I see you next time. Thank you.